Hello algebra students, and welcome back to another video lesson. So, same as usual, you're going to pause the video, you're going to try these problems in your notes, but first, I gotta show off this awesome shirt. You will understand it when we get to chapter 6, so that's something to look forward to. Math is radical. What does it mean? You'll find out. Okay, pause the video, try these problems in your notes. They are problems just like we learned about in the last video. And then unpause the video to do them with me. Okay, so solve the equation. First thing I do is I'm going to get rid of the parentheses. So I'll do 4 times 1, which is 4. 4 times negative p is negative 4p. I'll draw a line down there for my equal sign, and negative 4p plus 4 will just come right on down. Now, remember, I want to get my variables on one side of the equation and my numbers on the other. A lot of people like it when it goes p equals something, so if that's you, then let's put our variables on this side of the equation. I'm going to do that by adding 4p to get rid of this, and if I add it to one side of the equation, I gotta add it to the other side. So I will add it over here as well. And now I have negative 4p plus 4p. Oh. Well, that just cancels out too. Negative 4p plus 4p is 0. So this is just 4 on the left side equals 4. This is always a true statement. 4 always equals 4. So this means that there are infinitely many solutions. And remember, infinitely means more than we can count. There are so many solutions we can't even count them. So every single number that you could possibly think of, it is a solution to this equation. Okay, and let's put a box around it. Infinitely many solutions. Woo! Alright, let's move on to the second example. Oh, and remember that if you want to check, remember that this equation is called an identity because any number is a solution to this equation. If you want to check an identity, you can plug in any number you want. You can plug in p equals 1.2. P equals 5,126. Whatever you want, you can plug into that equation. And it should be a solution. You should get something that is true. All right, next problem. Parentheses first, always. So we're going to write down 6m minus m. 5/6 times 6m. Now remember that when you are multiplying by a fraction, you can just put the 6m over 1, because remember, anything divided by 1 is just itself. So if we put a 1 underneath it, we're not changing it at all. Okay, so then this is, oh look, those 6. We have 6 on the top, 6 on the bottom, we get rid of them. And this is just 5m over 1, which we just talked about. Anything over 1 is itself. So it's like the 6's just cancel out. And we get 5m, and then 5/6 times negative 10. Right, we gotta write this out again. 5/6 times negative 10 over 1. This is negative 50 over 6. And let's see. We can divide the top and the bottom by 2, and we get negative 25 thirds. And I think that is all we can simplify this. So we have minus 25 thirds. Oh, and don't forget your equal sign. Always keep the equal sign. Okay, now let's simplify both sides of the equation. I notice that I have an apple and an apple. I have 2 variables on one side of the equation, so we can combine like terms. 6m minus m. Remember, there's an imaginary 1 in front of here, so 6 minus 1 is 5m. And then bring down everything else on the other side of the equals sign. Now, variables on one side, numbers on the other side. So I noticed that on this side, all I have is a variable. So I think it will be easiest to get the m's over here and the numbers over here. So I'm going to get rid of this 5m by subtracting it from both sides. And now I will get, 5m minus 5m is 0. So I have 0 equals negative 25 thirds. Wait a minute. Is 0 equal to negative 25 thirds? Is 0 equal to anything that's not 0? No. So the answer to this is no solutions. No matter what you plug in for m, this equation will never work. It will never be equal. So, our answer is no solutions. Alrighty. Did you get them right? Did you make a few mistakes? Either way, your brain is growing. Good for you. Let's move on to what we have for today. Today we start our work with section 1.5. I know what you're thinking. 1.5, where did 1.4 go? Don't worry, we will eventually come back to 1.4, but we're going to skip it for now. So, section 1.5 is about rewriting equations and formulas. Today we work on equations. Next video we work on formulas. So the learning target is that you know what a literal equation is. Today is all about literal equations, so it is very important that you know what they are. And the success criteria is that you can rewrite literal equations. So today is all about rewriting literal equations. Now I know what you might be thinking. What on earth is a literal equation? Let's talk about it. A literal equation, all it is an equation that has two or more variables. So let's get a different color in here. Notice how in this equation we have y and x. Normally, we just have one variable. In our beginning task, we just had p. There was no p and q, it was just p. And in this example, we just had m. There was no m and x, it was just m. So literal equations are when we have two or more variables. So we could also say 12 plus 3z. And you could add another variable. You could say plus 8p. You can have as many variables in here as you want, but you need at least two for it to be a literal equation. Okay, that's what it is. Now, today we're talking about rewriting literal equations. So we talked about an equation that has two or more variables is called a literal equation. Just learned that in the last slide. To rewrite a literal equation, and this is what we're doing today. In order to rewrite a literal equation, you will solve for one variable. Solve for one variable in terms of the other variables. All this means when you say in terms of the other variable, it means that you get x equals 3p plus like 4z. When it says in terms of the other variable, it just means that the other variables are on the other side of the equal sign. So you have x by itself and the other variables are on the other side. So depending upon what these variables are, it's going to change the value of x. So that's why we say in terms of, because x depends, the value of x depends on what the values of these are. Okay, so in order to rewrite a literal equation, we're going to solve for one variable and get all the other variables on the other side. Sounds easy enough. Let's see what that looks like. Our first example, we're going to start out nice and easy. You'll notice that there's y and x. Just two. We're going to start with just two variables. So the most important thing about rewriting a literal equation is you need to know what you're solving for. Notice how it said solve for one variable. Which variable? Well, it will tell you. This problem says for y. If we are solving for y, this means that we want y equals blah, 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 whatever. So if we are solving for y, y is what we are trying to get by itself. Y needs to be all by itself. So the way that we are going to do this, let me rewrite this equation. We have 3y plus 4x equals 9. We want the y all by itself. So we're going to move everything away from the y. So I'm going to draw my line down the equal sign. So I want y by itself. So this 4x does not need to be here. I want to move it over to the other side. And remember, how I move things is I just do the opposite of it. So we have plus 4x, I'm going to minus 4x. And if I do it to one side of the equation, I must do it to the other in order to balance it out. So minus 4x. Alright, so now we are left with 3y on this side equals 5x? No, not 5x. Remember, this is an orange. This is an orange. This is an apple. Cannot put apples and oranges together. So instead, we just write 9 minus 4x. I can't put them together. It's okay to just write it this way. In fact, it's correct to write it this way. Writing it any other way is not mathematically correct. So we just have 9 minus 4x, and that's okay. Can't put them together. All right, now let's focus on our y, because that's what we're trying to get by itself. I notice that I have 3 times y. Remember, to undo multiplication, the inverse operation of multiplication is division. Dropped my pen. So I'm going to divide by 3 on both sides. Now remember, when you divide by 3, you must divide the entire side by 3. You can't just divide 9 by 3. You're messing up your equation. It's not balanced unless you divide everything by 3. Remember, we want to keep our teeter-totter balanced, so you must divide everything by 3. Okay, so now that goes away, and we have y equals 9 minus 4x divided by 3. And I know it looks kind of ugly, but that is correct. We can simplify this a little bit more if we want. Now, this is a correct answer. Your teacher might want you to simplify this a little bit more. So I'm going to show you how to do that. When you have something that looks like this, 9 minus 4x all divided by 3, you are allowed to do this. 9 divided by 3 minus 4x divided by 3. And the reason this is okay is because the 3, everything up here is being divided by 3. And in this expression that we wrote right here, everything is still being divided by 3. 9 is being divided by 3, and 4x is being divided by 3. So these, this, and this are the same thing, we just wrote them a little bit differently. And you'll notice that here, in this equation, what is 9 divided by 3? It's 3. It's 3. So I can write this as 3 minus, is 4? Can I divide 4 by 3? No. No, I cannot. So this will stay as negative 4x over 3. You can also write this as 3 minus 4 thirds times x. It's the same thing. 4x over 3 is the exact same thing as 4/3 times x. You're just writing it a little bit differently. So this, we have y equals 3 minus 4/3 x is another final answer you could have. I would accept this one, but if you really want to show that you've mastered the content, you will want to be able to simplify it further. Okay, wonderful. That's an example of when we just have two variables in our literal equation. Were we correct? Yes, we were, and look at that, they even simplified. Y equals 3 minus 4/3 x. Cool, yay, we were right. All right, so now, another example. This one is a little bit different because you'll notice it says that we are solving for x. That means that we want x equals blah, blah, blah. But when I look at the variables, I see x, x, z. That is 1, 2, 3. Now I have 3 variables. Now 2 of them are x's, but still I have more variables than I did in the last equation. This doesn't change things a ton, but it does change things a little bit. So let's rewrite the equation over here. Y equals 3x plus 5xz. And we want to solve for x. So remember that we are getting x by itself. Oh my goodness, I almost forgot. When we have y equals 3xz, we actually have 4. I was wrong. We have 4 variables, and only 2 of them are the same. So we do still have 3 different variables in this equation. Okay, so we're going to do something that we haven't done yet before. Remember when we had 2 times x minus 3, right? And we would say, all right, the 2 goes to the x and it goes to the -3, and I'm going to multiply 2 by x and 2 times -3, and I'm going to get something like this. So that's called distribution. We can do the opposite of distribution, and we can undistribute things. So if I have this, if I have 2x minus 6, well, I can pull a 2 out. That's what we call it, pull a 2 out. I can say, you know, let me put this 2 out here, and I can take another 2 and put it out here. So if I pull a 2 out, it's like I'm dividing this by 2, and I get x, and then I'm dividing the -6 by 2, and I get 3. So see how here we went from parentheses to no parentheses? But we can also go from no parentheses back to parentheses. This doesn't always work. Remember, you have to have something. You have to be able to divide 2x by 2 and 6 by 2. And it works in this case. It doesn't work in every case, but it does work in this case. So notice right here how I have an x over here and an x over here. So here I had a 2 here, and there was a 2 like secretly hidden in this 6. So I could pull the 2 out right here. Because there's an x here and an x here, I can pull these out in front and undo the distribution. Now I know you might be confused, so let's see what this looks like. I am going to pull an x out. And in fact, we'll keep our y equals, but I'm going to pull an x out because there's an x here and there's an x here. So I know I can divide by x on both. So 3x, if I pull the x out, there's no more x, and I just have 3. Plus, if I pull the x out of here, there's no more x, there's just 5z. Like that. Like that. And we can check and make sure that we did this correctly by taking this, x times 3 plus 5z, and we can redistribute and make sure that we get the same thing as up here. So x times 3 is 3x, and x times 5z is 5z times x, or 5xz. Typically, they like you to write the variables in alphabetical order, so we wouldn't write 5zx, we would write 5xz, because x comes before z in the alphabet. And look at that, this is the exact same as what we have up here, which means that we undistributed correctly. So, let's do a recap. That was a lot. We took these x's right here, and we pulled them out into this x right here. Now, I know what you might be thinking. Why? Why did we do that? Well, remember that we are solving for x. We are trying to get x equals something. So we're trying to get x by itself. Here, x is more by itself than it was up here. So, here we go. Okay. So now that we have, remember what this means is x times 3 plus 5z. What's the opposite of times? Divide. So, all I have to do is divide this side by 3 plus 5z. But wait, if I do it to one side of my equation, I have to do it to the other. So I'm also going to divide this side by 3 plus 5z. So it goes away on this side. I don't have the 3 plus 5z anymore. And instead, I am left with y over 3 plus 5z equals x. And the x is by itself. So we did it. We did it. Now, we talked about checking our solution a lot this chapter. You can check the solution of a literal equation by plugging it back into the original equation and seeing if you get the same thing on both sides. We are not going to do that because it gets kind of messy. I mean, you already see the more letters we have, X, Y, Z, P, the more letters we have, the more complicated things look. So you totally can, and in fact, if you want to try that, I would say more power to you. That would not be a bad idea, but I don't want to confuse you, so we're not going to do it here because it's not completely necessary. Okay, wonderful. Let's make sure that we got it right. Beautiful. Y divided by 3 plus 5z. X equals y divided by 3 plus 5z. We were correct. Okay, and this blurb down here is just telling you that the denominator cannot be 0, because remember, if we divide by 0, the world will explode. Okay, so now, I know those examples might have felt a little fast. Remember that you can change the playback speed of this video to 0.5 or 0.75 so that it slows it down for you. You can pause it, you can rewatch pieces of it if you need to. But I want to give you an opportunity to solve, to try it yourself. So, here, this is like the first example we did. This is like example 1. And this is like example 2. I would like you to pause the video and try these problems. See how they feel. Do you completely understand what we did today? Or are you still like, I'm very X, Y, there's too much going on. Where are you at? Rate yourself. Are you 1, I know what I'm doing? Or are you like 3, like I don't know what I'm doing? Where are you on the scale? So try these problems and then unpause the video, and we're going to do them together right now. Let's do some different colors. Okay, I am solving the first one for y. That means I want y equals blah, blah, blah. So, first thing I'm going to do, I'm going to draw my line so I can see the different sides of the equation. I want y by itself. which means that I need to get rid of the 8x. The opposite of positive 8x is negative 8x. So I will subtract 8x from both sides. And now these go away. And I have 20 minus 8x. Remember, I cannot put these together. This is an orange, this is an apple. Can't put oranges and apples together. So we just leave it this way. We leave it as 20 minus 8x, and that is good. That is equal to 4y. Hey, look at that. Y is almost by itself. We just need to get rid of this 4. Now this right here is 4 times y, so we will divide by 4 on both sides. That gets rid of that 4, and now we have 20 divided by 4 minus 8 divided by 4 times x. And that is equal to y. Whoops. And I wrote it this way because remember that we can split this up. I'm dividing the 20 by 4 and I'm dividing the 8 by 4. So that's what I did right here. 20 divided by 4 and 8 divided by 4. And now I know what 20 divided by 4 is. 20 divided by 4 is 5. And I know what 8 divided by 4 is. 8 divided by 4 is 2. So I end up with 5 minus 2x equals y. Alrighty. Beautiful. Beautiful. Okay, let's move on to the next one, but we'll use a different color. Now we are solving for x. So I want x equals something. Okay. First thing I notice is that I have an x here and an x here, which means that I can undo my distribution and I can pull the x out over here. Now, if I pull an x out of this, the x is gone and I'm just left with 2. And if I pull an x out of here, I am left with a k. Now remember, the x isn't completely going away, it's just going right here. So I'm just moving where the x is. All right, and this is equal to m. Now, I have x times 2 plus k. The opposite of times is divide. So let's divide by 2 plus k. You can keep the parentheses, or you can get rid of the parentheses because we're dividing by the whole thing. Because all of the 2 plus k is underneath this line here, you don't have to have the parentheses. But if you want to keep them, it doesn't matter. We'll divide by 2 plus k on both sides. And now it goes away over here, and we are just left with x, and x equals m divided by 2 plus k. And x is all by itself. That's what we wanted. So we have solved for x. Woohoo! Awesome. How'd they go? How'd the problems go? If you struggled a little bit, maybe you want to rewatch the video. Maybe you want to call a friend and see how they're doing. Maybe they can help you with it. Maybe ask your teacher. If you got it, if you're like, oh yeah, I got it, awesome. Good for you. Maybe you want to do some practice problems to make sure that you got it. But remember that if you do have questions, if you were confused about anything in this video, ask your teacher, ask a friend, rewatch the video, whatever you need to do to make sure that you got it. Because if you move on to the next thing without understanding this one, it's just gonna get more and more confusing, and we don't want to confuse you. We want to help. All right. And if you want more practice problems, I know this looks like a lot. There are 20 problems on this screen. These are not necessarily the questions that your teacher has assigned, but they will help you. Remember, it says see example 1 right here. That means that all of these problems are like the first example we did. And here it says see example 2. That means that all of these questions are just like the second problem that we did, the second example that we did. So, if you were like, oh, I know how to do example 1 problems, I got those, they feel good. Cool, maybe you don't do these ones, But maybe you struggled with example 2, so you really want to work on these. Whatever works. Whatever works for you. Okay, so those are the practice problems should you want them. And just as usual, we are going to end the video with a launch. Launch you off to the rest of your day. So, life is like riding a bicycle. To keep your balance, you must keep moving. You must keep moving. So, I mean, most of you have ridden bicycles before. You know that if you stop, you're gonna fall over. And the analogy here, life is like riding a bicycle, is that sometimes we get nervous about doing the next thing. We get nervous about taking the next math class. We get nervous about asking the girl we like to homecoming. Or we get fixated on something that happened in the past. My boyfriend dumped me, or I failed the last math test I took, or the last English paper that I wrote. And we get stuck in this, I don't want to move forward, or I wish I could change the past. And getting stuck with worrying about the future or worrying about the past it's just going to tip your bike over. And that's even more painful. Then you skinned your knee, you gotta put a band-aid on and get back on the bike, and then you're even more nervous. So, if you keep moving, if you don't fixate on the past, forget about the boyfriend that dumped you. You will find someone better, and I know it doesn't feel like it. When my first boyfriend dumped me, I was like, no one will ever love me again. I'm so obnoxious. I'm so annoying. I'm married now. I thought nobody would ever love me again. You will find love again. So, don't worry about the future. Don't worry about the past. Keep moving. Keep moving. Take the next thing that comes at you, and life will become a little bit better for you. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.